Hey there, everybody. Welcome back. It's Mr. Noldy here at Planet Numeracy. And today I was going to show you a couple of examples on how to solve nonlinear inequalities. Fun stuff. So let's get right into it. Good afternoon, sports fans. Mr. Noldy here again, and we're going to do a quick review on solving nonlinear inequalities. So what does that mean? Well, it means they're nonlinear, means like x squared, x cubed, things like that. We'll focus on x squareds, quadratics today. And inequality means it's got no equal sign. So that'll be like less than, greater than, less than or equal to, greater than or equal to. So we're looking at functions that are inequalities, okay? So let's go to a quick problem. Ready for the first one? Here we go. Here is a quadratic, all right? We have a quadratic here. So it's got an x squared, and it's kind of written in general form, except no equal sign here. It's a less than sign. Remember, we're looking at nonlinear. This makes it nonlinear. Inequalities. This sign makes it an inequality. So the first thing we want to do is still factor these things, just like it was an equal sign, just like this was equals. So I'd factor this. Let's see. Factors of 4 that add up to 5 are, this factors nicely into x plus 4 and x plus 1. So easy to double check this. 4 times 1 is 4, and 4 plus 1 is 5. So if this were an equation right here, I'd say if this times that equals 0, either this equals 0 or that equals 0. But with an inequality, we don't say if this times that is less than 0, then either this is less than 0 or that is less than 0. That's not how these work out. So what we want to do is kind of pretend that this is an equal sign. And if it were, I would get x is negative 4 and x is negative 1. So I'm just going to jot that down. X would be negative 4 and x would be negative 1. Now what we're finding those out for are just numbers that we can put on a number line. The easiest way to do these is to just make a number line. And let's see, negative 4, that would be down here. Negative 1, that would be up here. And then we need to test values in each one of these regions. So I need to test a value less than negative 4. And I need to test a value between negative 1 and negative 4. And then I need to test a value greater than negative 1. And I'll show you how it goes. So the first thing we do is we write down the two factors, x plus 4 and x plus 1. Then I'm going to write down the product, x plus 4 times x plus 1. So my favorite number less than negative 4, it really doesn't matter which number you pick. Any number less than negative 4 will work. But in this region, if I pick, say, negative 5, and I substitute, what's negative 5 plus 4? Well, it's negative 1, but the only important thing is that is a negative number. Okay? Then let's see, what if I put a negative 5 in place of this factor? Negative 5 plus 1, that's also a negative number. So what is a negative times a negative? So when this region, less than negative 4, this is negative and this is negative. So negative times negative equals what? It equals a positive. All right. Now we'll go on to the next region. So between negative 4 and negative 1, let's pick, say, I don't know, negative 2. So if I substitute a negative 2 over here, negative 2 and 4, well, that's a positive number. And then if I said, what is negative 4 and 1? Well, that's also a negative number. And if we multiply positive times negative, we get a negative. negative. And then one last region to check up here, greater than -1. So here we go. If I pick, say, I like 0 because 0 is easy to plug in over here and check. So let's pick a 0. What is 0 plus 4? Well, it's 4, but the important thing is it's positive. And let's see, if I put 0 in place of x here, what is 0 plus 1? Well, that's also positive. So then we have positive times positive. Here it is, positive times positive. That gives us a positive. Positive. We'll try that again. All right, so notice back in the beginning problem, we wanted this product to be less than 0. So that means negative. So when we do our testing, this is not negative, so it does not work. This one is also not negative, so that region does not work. But winner, winner, chicken dinner, we'll give that the green all-in check mark if you watch poker. So this region is the region that solves this inequality, this original inequality. So how do we write our solution? Well, there's a couple of ways we could do it. Usually in pre-calculus, we will write down a interval notation solution like this, from -4 to -1. The reason for the parentheses here, why do we get parentheses here and as opposed to brackets? Well, there's no equal sign. It's just less than. There's no equal sign. If we had an equal sign, we'd have to use brackets here, but there's not. The other thing you might be asked to do, depending on your textbook, I suppose, is you might be required to draw the answer on a number line. So make sure you have a -4 on the number line, and I guess I will count all the way up to -1. So remember, there is no solution that is exactly equal to -4 or -1. So when we graph this, we're going to put a open dot around the -4 and around the -1, and everything in between solves this inequality. So we would shade in between. So those are two different ways of showing the solution, either by writing the interval or doing it on a number line. So I hope that was helpful for you. Stay tuned. I'll show you one more quick example. Okay, so here's another example. Notice that this one is not arranged so that it's equal to 0 or greater than 0, I suppose. So I'm going to need to do a little bit of rearranging first. So the first thing I'm going to do is distribute this -3. So let's do that. Oops, do you like pink? We'll stick with pink. X squared is greater than 3x plus 18. Then I'm going to move everything from the right-hand side here, move it over to the left-hand side. That makes it x squared minus 3x minus 18. This one is greater than 0. So no equal sign again. So that means we're not going to have closed dots on a graph. We're not going to have brackets on an interval. It's going to be parentheses. So let's factor this. This is the way we do it. X, let's see, x plus 3 and x minus 6. So we can double check that quick. What's 3 times -6? Well, that's -18. Positive 3 and a -6 add up to -3. So everything looks good. So if this were in equality, if this times that equaled 0, this would be 0 or that would be 0. But that's not how we do this. We're going to say if it were an equation, well, I'd be looking at x equaling -3 and x equaling 6. So then sometimes we call these cutoffs. So I'm going to make a number line that has the -3 and the 6 in it. So this is just a graphical organizer that helps us with what goes where. Let's see, I got a -3, got a +6. Actually, I'm going to put these up top this time. Let me erase that. So my two factors, well, let's say I have x plus 3 and x minus 6. And then we are multiplying them together, and we're looking to get what? We're looking to get something greater than 0, so positive. So in this region, we need to pick a number less than -3, say -4. -4 plus 3, well, that's negative, a negative number, -1. -4 minus 6, -10, so that's also negative. But when you multiply two negatives together, you get a positive. So that's what we're looking for, is positive. So this one works. Give that the green check mark. Now let's go to my favorite number between -3 and 6. It's got to be 0 just because it's easy to check over here. So let's see. 0 plus 3, that's positive. Oops, let me switch back to my original color here. That's positive. And let's see, we also have 0 minus 6. Well, that's negative. And negative. So what's positive times negative? Positive times negative. That's going to give us a negative. So this one does not work. So it gets a big old X. Well, yellow X. But that'll work. Next, let's look at our final region. Anything bigger than 6. So my favorite number bigger than 6 is 7. So 7 plus 3 is 10. So that's positive. I keep getting the wrong color. Then we are going to say 7 minus 6. Sorry, 7 minus 6. That is also positive. And when we multiply this out, positive times positive, positive times positive, that yields a positive product. So, and we wanted that's what we were looking for, greater than 0. So that will also get a green check mark. All right, so notice a little bit of a difference here with this, the greater than. Instead of shading a region in between, we're going to shade regions in the exteriors. So things that make this inequality true are anything less than -3, but not equal to -3. So we're just going to say -infinity up to, but not including the -3. So again, if this had been an equal sign, greater than or equal to, this would be a bracket, but it's not. And then we're going to combine that with, a lot of times you'll see it with this, union, and everything out here from 6 to positive infinity. But it doesn't include 6, again, because no equal sign. So 6 to infinity. So that is interval notation. If you were going to draw a number line, you'd make sure you had, what, your -3. Let's see. I'll start down here at -3, -2, -1, 0, 1, 2, 3. Oop, got to make my line a little bit longer. There we go. And 6. I'll put a 7 for good measure and maybe a -4 down here. So basically, not basically, actually, everything less than 3. So open circle because, again, way back here, we had no equal sign. It was only greater than. So from -infinity to -3, but it doesn't include -3. The other direction, we had 6. Got to move my line back over. 6 to infinity. So here it goes. open dot at 6, shade the line to the right. And that is another example of how to solve a nonlinear inequality. So I hope that helps you out. If you have any other questions, you can put it down in the comments below. And I'll try to keep making more of these videos. I have not made one in a little bit. So thanks for bearing with me. All right, thanks for sticking around for that. I appreciate it. If you got some value out of it, go ahead and hit the like button and maybe even subscribe. Until next time.